What's up everyone, and welcome back to the 9th video in the Python tutorial series. In this video we're going to be covering break and continue statements, and so this is actually going to be kind of the culmination of a lot of the previous videos we've done. So we're going to be doing for loops, we're going to use the range function, we're going to do if else, and then we're going to also add in break statements and continue statements. So for today what we're going to work on is basically a simple system that's going to find prime numbers. I'm going to type this out and then I'm going to explain what it's doing. So basically this is like we've done in the past. We're going to do for n in range 2 through 10. So it's going to look at the number 2, then the number 3, then the number 4, all the way up to 9, but not including 9, so it's only going up to 9. And then within that, it's going to look through the numbers 2 to n. So it's going to start at 2 to 2, which is nothing, because the range of 2 to 2 is 0. Then after that, it's going to do 2 to 3, because n is going to be equal to 3. I'll print it out later once we have a little bit more to show, and I'll explain. And then in this line what we're doing is an if statement, and we're using the modulo command. So basically we're going to take n modulo x, which is basically what's the remainder of this division. So it's n divided by x and then whatever the remainder is. And if it's equal to 0, that means that the x is a factor of n, which means that it's not a prime number. And then here what we did is basically we just made a statement. We're doing print the number n, so it might be 2, 3, 4, whatever, equals x times, and then whatever the ground division n divided by x was. So if we find a factor of n, then we're going to break out of this for loop, and it's going to move on to the next number. So instead of, say if it's looking at the number 9, which is the highest number, it's going to get up to 3, and it's going to find that 3 times 3 equals 9, and so there's no reason to check 4, 5, 6, 7, 8, 9, because we know that 3 times 3 already makes it a non-prime number. Or, a non-prime number. And basically what this statement is if we don't find a factor that creates a 0 remainder, then we can assume that the number is prime. So I'm going to run this. I'll scoot it up a little bit. And we can see it found 2 as a prime number, 3, 4, it found 2 times 2, 5, 6, 7, 8, 9. And so now what I'm going to do is I'm going to throw in some print statements so we can see a little bit better what it's doing. So it's going to print n every time, and it's going to print x every time. And so we can see it did 2, it printed 2, and then for x it didn't print anything because it was the range of 2 to 2, which is nothing, and so it just skipped directly down to 2 as a prime number. Then we check 3, 3 being n, and then x is 2, and then we find 3 divided by 2 does not get a remainder of 0, so then it is a prime number because that's the only number we can check. Then we move on to 4, and 4 checks 2 first, and it finds that 4 equals 2 times 2, so it is not a prime number. And so basically that's the flow it's doing. And like the example I explained before, it's going to check 9, or the last number is 9 in the first range, and then in the number it's checking, it's going to check 2, didn't find anything, it's going to check 3, and then it finds that 9 equals 3 times 3, and because of the break statement, instead of continuing through the for loop, it breaks out of this for loop, and it moves to the next number in this for loop. And that's basically the usage of the for loop. And then the next thing we're going to work on, I'm going to just clear this off. We're going to check to see if a number is even And we're going to change this to num to be consistent with what they did. And we can print that, and it's going to find an even number, found a number. And so basically what this is doing, it's doing the same modulo check. It's saying if a number is divided by 2 and it has a remainder of 0, then we're going to print found an even number. But if it doesn't, then we're going to print just found a number. And what continue is doing is continue is just moving it back to the beginning of the for loop and continuing on the next letter. So if we didn't have this statement, I'll show you what it does. It's going to print found an even number, and then it also found a number 2. And so what the continue statement is doing is instead of continuing down to the next line, it goes to the next number in the for loop. So I'm gonna have these run side by side so you can see exactly what it's doing differently. So we can see on the top one with the continue statement, it's found an even number, found a number 3. But down here, it's found an even number, found a number 2. So it's doing both statements when we don't want it to. So the continue is very useful if we want it to just move on to the next item within a for loop or a while loop. I think actually just a for loop. Sorry, I misspoke. But that makes it so we can move on giving the correct condition, which is very useful when we're programming. That's going to be it for the break and continue statement. In the next one, we're going to be doing the pass state. Sorry, the pass statement.